Our next presentation is Thedore Pham, and it's on supply chain attacks. Ted is director of InfoSec of the InfoSec office at Carnegie Mellon University. Ted, welcome.
Thank you. It's a pleasure to come speak to you today. I'm one of those dreaded IT security guys that you keep saying. I'm one of those dreaded IT security guys that it seems like you guys don't like very much. But hopefully by the end of this talk, you'll actually like me. So how many of you know, what happened with SolarWinds 2 years ago? How many of you know the nitty-gritty details of what they broke into? Okay, well, they broke into us, and I'm gonna tell you about it. But first, I'm gonna give you a little bit of information about CMU. And then we'll talk a little bit about my information security office and my team. Then I'll go into what we saw with SolarWinds. We'll talk a little bit about SolarWinds in the world. I might skip some of those slides. And then we'll get to the lessons learned. So first of all, CMU, who we are. We've got about 16,000 students. Faculty, there's about 1,500. There's another 4,500 staff. So about 6,000 faculty and staff total. And we have 125 living alumni out in the world who all have email accounts. We're a global campus. We have our main campus is in Pittsburgh, Pennsylvania, but we also have global campuses in Doha, Qatar, out at Moffett Field in California, at Silicon Valley, and another campus in Rwanda, which is what CMU Africa is. We have more than 12 degree programs across 20 research locations around the world. And last year, our sponsored project revenue was just under $448 million. We have 7 different colleges. CMU prides itself on being an interdisciplinary place. We have the best in the arts, design, computer science, technology, and engineering, all mixing together, marrying the technologies. And we have some very interesting majors that, like business administration for the arts is one of our degrees that we confer. There's 80 different major programs, 90 minors across the 7 colleges. We also are home to a number of the pretty famous research institutes and research centers. The most recent one is this Advanced Robotics for Manufacturing Institute that just stood up, revitalizing a steel mill and turning it into a next generation research and development facility. We have NREC, where you might know about the self-driving cars and the Grand Challenge we won in 2007. PSC, shout out to my PSC friends. And last but not least, we have an FFRDC, which is the Software Engineering Institute, and home to the original Commuter Emergency Response Team. So we are literally the home and the bed of cybersecurity. My team is composed of 22 people. 10 of them are on kind of the training and awareness, policy, access management, identity side. And the other ones of us are part of the actual operations team. So most of us take shifts in the SOC. I visit the SOC from time to time and do shifts in there. I'm an escalation point. All my engineers work in the SOC as well. So here's a little bit about what happened. I'm going to start from the defender view. So we're going to look at the blue dot first. So on August 12th of 2020, I get a Slack message from my team saying, hey, there's this funny internal IP address that's on some academic unit's VPN that's scanning our network. That happens semi-frequently, so we go chase it down, and we're not sure which VPN this is because we haven't seen it in a long time. So we work back, and within hours, a couple hours, we realized that there's been other compromised accounts coming in, some of them privileged accounts, not full root access, but privileged accounts. And so we start to get a little worried. We start looking through more logs. We realize that we haven't ingested all the Windows logs. We haven't ingested all the logs we need in that academic unit because it's kind of their responsibility to get the logs to us. So we start having to go out to machines, pull data. We finally work back and realize that there is a C2 beacon on one of the servers for the department, with the academic unit. And there's a Mimikatz detection from Windows Defender on the Windows box. And if you're not familiar, that's the thing that you run to pull password hashes and potentially plain text passwords out of a Windows box. From there, we find that someone has a domain administrator account and is able to do this. And we work back and we find there's some strange DNS coming off the box, right? Some funny DNS requests that we've never seen before come off this box. And it's contacted 3 of the Active Directories for other departments across campus, which is weird, right? Usually the Active Directory serves that one department. It doesn't usually cross over. At this point, we're getting kind of worried, right? It's contained to the academic unit. We see kind of brute forcing attacks using their credentials against our centrally run Active Directory. And we decide at this point, okay, we're in the middle of the pandemic. Part of my team is working on other things to help the mission of the university, like trying to actually survive the pandemic and figure out where people are and figure out the density of various buildings. So we decide, hey, we've got an IR retainer. Let's use it, right? Let's get some staff augmentation in here. So we activate our cyber liability insurance. We grab Mandiant, FireEye, because they're the best in the business, and getting them on your retainer is usually what you want to do as an R1. We call them in on the 20th of August. They start looking around. We hand them all the information that we've got, and in the meantime, we find out that there's a network connection between another server that started on the 22nd, right? There was another machine, and that machine just happens to run SolarWinds. We give this to Mandiant. We concentrate on getting more logs into the system, giving them the data that they need to do the investigation. We then push out their agent, right? So most EDR, when you start an IR engagement, if you don't have an endpoint detection and response solution in place, the first thing they're going to want to do is they will deploy their software to as many of your machines as possible. So in this case, it was just shy of 4,300 machines. And that takes a while. And people are not happy when you put this agent on their machine, because when you're doing it very quickly, you tend to overlook things like actual testing and dev time and understanding the repercussions to the mission of the university when this happens. But you have to do what you have to do, and you have the CIO's backing to do it. So while we're doing that, the Mandiant folks they start looking for data. They uncover the source of the C2 DNS requests coming from this server 1, we'll call it server victim 1. And they realize they find the file, they look at it, they realize it's a custom compiled Cobalt Strike. And they're just monitoring it at that point. They're digging. We eventually get to the SolarWinds box. We see funny DNS traffic coming off of it too, but we're not sure why. We can't pinpoint how the SolarWinds box is compromised. Right? All the software checks out. Everything is signed properly. Nothing looks out of the ordinary. So we finally take that server offline, and while we're waiting, on the 1st of September, we find that beacon that we left in place on the first server magically disappears. We've been resetting credentials for various people within the academic unit, and we missed a couple. So the intruders came back in and removed the back door, right? At this point, we think the SolarWinds server's fine. We bring it back up. Mandiant finishes their investigation. They can't find out where the source of this compromise is. That's around the 16th of October. They go work on the report. They deliver it to us on November 6th. We just sit back and we've defended things. We've got things back to normal. We've started doing all the password resets. We did the golden reset on the Active Directory for that department. All well and good. Until December 13th. I'm sitting at home. I'm putting my kids to bed. And I just happen to look at my phone. Oh, Mandiant, or FireEye, they're the same company at this time, announces that they were breached. And they traced it back to SolarWinds. And so I text my boss and said, oh, look, they're reporting that they were breached by SolarWinds. I wonder if this has anything to do with us. And lo and behold, it did. But they didn't use any of our data to find the compromise. They used their own data because they themselves had been hacked. Now, it wasn't the whole company. It was their penetration testing tools division, not their monitoring and EDR. But think about that. I'm sitting here in my home. I'm texting my boss. So I think I have a supply chain attack dating back to July when we installed the update on the 7th. And it started going active on the 10th until they finally, or it started calling home, waiting for instructions, and then they finally gave it an instruction on the 22nd, right? And at the same time, I'm wondering, wait a minute, I just installed the Mandiant agent on 4,000 machines in my institution. Did I just compromise those 4,000 machines by trusting this vendor, right? So that's where I'm at. And then we take a stock and say, okay, where are all the other SolarWinds-based products out there that are affected by the Orion hack? And we find there's another one. And it was installed on May 5th. Can anybody tell me why you don't see other points in that lower timeline? Anyone want to take a guess? No one? Lucas? So the central IT run systems have lots of security controls. One of them is we don't let them egress to the things they're not supposed to egress to. So it never could call home, and it was basically inert. So Microsoft was swept up in all of this, and Brad Smith, their president of security, I think at the time, said this is the largest and most sophisticated attack the world has ever seen. And I will let you, I think everyone in this room probably knows who they think was behind it. Just some other quick details. It turned out that SolarWinds, the vendor, had been hacked all the way back in September of 2019. They had added malware to their build system, their software build system. They did a test balloon just to see if they could sneak something through, get it properly digitally signed, and out to customers. They succeeded. Again, it was just a test. It didn't actively try to do anything malicious. They waited 5 months, and then they came back in February 2020 and put actual malicious payload in the software, which was pushed out and installed by nearly 18,000 organizations. Right? You can see all these DNS beacons that are happening from them, from passive DNS data that the backbone providers have. But the number of actual organizations that were fully compromised is in the low hundreds, right? These were hands-on keyboard types of attacks, not automated, because they were very stealthy, very good operational security for their tradecraft. Some of the more interesting things they did, when you think about the supply chain attacks, is they went after the authentication sources, right? The previous talk was just telling us about how important it is to have trust and identity in research. Well, it's also important in your operational IT as well. So who in this room uses Duo? Two-factor? So if you steal the Duo integration secret, you can mint a Duo session, and then you can bypass two-factor without ever touching the Duo service. Likewise, these threat actors had a new way of stealing the private signing key for Active Directory Federation services. So what does Active Directory Federation services get used for? It's usually used so that you can let your on-premise AD passwords authenticate you to Microsoft 365 and Azure. So if they get this key from your on-premise server, they can now get into your Azure cloud and pull everything they want from there, because they can fake pretty much any account in the AD. And again, more cloud services providers were targeted here, right? So you all probably purchase cloud services from a reseller. That reseller has admin access to your environment. And if they're compromised, they can turn around and use it against you. This is what happened with Malwarebytes. They had a mail hygiene solution that they weren't using, but the credentials were still there. And the threat actors were able to get those credentials and then read Malwarebytes' email. So they targeted security vendors specifically because they know security vendors tend to have a lot of access to the kingdom. These are the bunch of other technical references you can read in deep detail for more information. Now on to the lessons learned. The first thing is, think back to why that lower timeline was so short, right? It wasn't anything fancy. It was the fact that we had taken the time to realize what things our server reaches out to, not what comes in, right? Because usually you have to let a lot of stuff in, and that's fine. If that's what the role of that service is, coming in is fine. Coming in to fetch data is fine. But don't let it get out. Like, when we think about what happened with Log4j at the end of 2020, right? The magic was you sent this special message, it started to load code from random places, and it could have come from random places in your infrastructure. Wherever that message you sent gets logged. It didn't have to be the web server. It could be the database server or an application server 3 times removed, like the wormhole of where this came out. Well, those servers don't necessarily need to talk to the internet. They need to talk to your front-end web server. So set your egress controls to limit it to what it needs to talk to on the outbound path. That's one of the magic tricks. Sorry, I missed the first one. Defense in depth, right? Things failed for us in this, right? We didn't have the right logs in place. We didn't have the right data coming in. In some cases, we lost data because it rolled before we could look at it. But still, we had layers of preventative controls and detective controls that compensated for each other when they failed. So defense in depth. Use multiple controls, make sure they're overlapping, because sooner or later, a single preventive control will always fail on you for one reason or another. The more you slow down your attackers by giving them things in their way of moving around your systems and gaining your credentials and getting out of your network, the more time you give to your defenders to figure out what's going on, right? So as Josh said yesterday, right, the harder you make it for them, the more likely they're going to attack somebody else, right? So the Trojan software has been out there since May. And in our case, we didn't get hit until July because we must have been pretty low on the totem pole because they were going after government agencies to start with. So the fast detection, fast recovery gives your organization resilience. Pretty much today in security, you assume you're breached until you can prove otherwise, and you continuously look for the fact that I'm breached. That's how the game is played. So I wrote security as a team sport on this slide. I think I'm wrong. The mission is the team sport. Security helps the mission get done. And as practitioners, we have to remember that we do what's right and we do what's possible the best we can. We don't do security for security's sake. That's up to the vendors who get hacked. So everyone has a role in security, and realize that you are not always the target. Your system could be just a stepping stone to the other systems that are the target. We strongly believe that the academic unit that was compromised was just a stepping stone to us, the central, because if they got into our central systems, they would be able to get into the individual emails of all the admins of all the departments and get any data they wanted at that point. Meet people where they are, right? Understand the limitations and maturity of all the organizations that you deal with and calibrate for that. I think Joe said it yesterday when I asked him about this whole notion of building trust, right? That you need to be listening for understanding and making those connections and not necessarily always listening to respond. That goes for lots of things in life, not just security. And always ask for feedback. Feedback is a gift, right? Feedback is how you improve. Failure is how you improve. You learn much more from failure than you do from successes. Build those relationships. Find out what your why is. I'll tell you what my why is, right? My why is I've been at CMU all my adult life as either a student employee, or staff member, right? I put 23 odd years into my IT career, 17 of those in security. And the reason I do it every day, the reason I get up every day, is because I firmly believe I'm defending the now so that I can protect the future. So the other people can make the world a better place, because I can't. All I can do is try to keep you guys safe. So build relationships, find the why, find the common ground. This last one, prep and step. Test your backups, make sure they work. Don't do a tabletop exercise, actually do a full restore and make sure they work, because you'll never know when you'll need them. Never waste a teachable moment or crisis, right? Always prepare and be thinking about what is your next ask? What is the thing that you need to do your job more effectively? And be prepared for that moment when the shit hits the fan and they give it to you. You need to know what you're asking for to be more effective. And finally, got confused. Make sure you're running tabletop exercises to create teachable moments, right? You don't have to have one of these crises. I have 10 minutes left? Oh, I have 10 minutes left, okay. You don't have to have a crisis. You can manufacture one using a tabletop exercise. You can learn how people think, as Helen said on the first day in the keynote. And this is just a little one for everyone who's dealing with cyber liability insurance. The premiums are going up, the deductibles are going up, and the coverage is going down. And there's lots of gotchas in there now. But understand the ins and outs of your policy, understand your requirements for reporting, understand your requirements for notifying them should you have any type of breach. Most of the time, they want to know about the little ones as much as they want to know about the big ones. And finally, if you have an incident response retainer, look at the rate you've negotiated with them and ask your insurance what their rate is going to be. Oftentimes the insurance, what we found is the insurance actually had a better rate. We didn't need the IR retainer. We could just, if we ever needed to use it, they would get us a better rate. They would be able to get the engagement for us. And because I didn't really talk about supply chain itself, I'm going to give you this nice reference from NIST that if you need to go to sleep late one night and you can't, read the NIST publication. Thank you. Take questions.
So I'm going to start off, Ted. So first of all, thank you for sharing this experience. I know it's not the most pleasurable thing to get up on stage and talk about a bad time that you went through, but it really helps the community learn from the experience that you went through. You noted that your staff was remote. Mm-hmm. You know, we've got a lot of, we've got the remote work that's extending now through year 2 of the pandemic. I'm curious to see if there was anything that you, after coming out of that whole incident, realized, oh, now that we have more people remote, we have to tweak our incident response procedures in a certain way, or there's certain things that we just didn't have in place because, we were, as you said, at home trying to get people to be able to work remote securely. So I'm just curious if there's anything that you changed in your program, your incident response program after this, based on that whole.
Yeah, so I mentioned that you get that opportunity, right? Don't waste the crisis. I'm in the middle of trying to roll out endpoint detection and response, another vendor, to my whole university. And I'm going to have to, I met with faculty members on Monday before I got on the plane, and they said, heck no. So I have to go back and convince them that they need to be my champions and teach me how I get people to accept this.
Thanks, Ted. My question is actually very similar. In regards to not wasting the teachable moment, did this event change the way that you apply security controls to your vendors or to your identity management? And were you doing that before, and did this change the way you approach that since then?
Yeah. So I mentioned the big failures when we did the postmortem were the fact that we didn't have the data, right? So every time we have one of these with the department, we transform the department. Right? We go in and we say, they come in, we work through the incident. We don't blame anyone during the incident, right? The worst thing you can do is blame the people you need to help you figure out what to do next, right? So we don't blame. We help as much as we can. We get them back up on their feet. We reassure them this is not an existential crisis. We will get through this. We've done this before. And then afterwards, we sit down and say, this is how we think you should change. What can you do? And we figure out the low-hanging fruit. We figure out the midterm, the long term, and we hope we get to the long term, right? Get the low-hanging fruit out of the way, get some of the midterm stuff, and cross your fingers you can get to the long term.
So at one point you mentioned that there was a phone home, and that was a regular occurrence. And you were detecting those, of course. And at the University of Chicago, of course, we also kept a dictionary of all the different kinds of beacons that the world knew about, and we're always looking for those things. And you also mentioned that there's this, and so many of those are buried in DNS, bogus DNS messages. And you mentioned that there's some on various the ISPs capture that kind of stuff.
Yep.
And so there's data that can be mined, and I'm wondering if anyone, this isn't necessarily a question for you, but more for the room, is anyone doing research in creating services out of looking at that data? I can imagine, I mean, we've detected some supply chain attacks at Chicago based upon observing these phone homes, these pings. And I'm wondering if there's anyone out there trying to help the world detect these things as opposed to leaving it to each leaf node on the internet.
I believe there are security communities that do. Team Kumari comes to mind. The REN ISAC does some work on passive DNS and making the data available. I don't know if we have been anonymizing it to make it available to researchers, but we do use it internally.
So I wonder why, is this thing back on? Okay. I wonder why no one peeped about that with the solar wind.
I don't know. Honestly, I don't know. Because we were stymied, right? We were looking at the data. We had the DNS request. We just didn't make the leap in our heads that it could have been the actual signed software that had been Trojaned. And us and Mandiant standing right next to us, neither of us figured it out until we heard the report. And I contacted the company. I asked, did you use our data? Was our incident involved? They couldn't tell me. I had to get the open source indicators and compare and realized, oh yeah, it was. And then we met up afterwards and had briefings.
We had, by the way, just for universities, for research centers, we had a similar thing. It didn't have the same impact as solar winds, of course. But there was a manufacturer of, I forget what kind of $1 million instrument that we had a few of in our labs. And they had, it turns out, a botnet client installed in their software. So we detected one, it phoned home. We figured out where it was. We flashed new software in from the manufacturer, turned it on, phoned home. So they realized that they had been compromised. And wherever this thing was being deployed, usually at very, R1 kinds of places with very large network capacity, they were now positioned to take advantage of that to launch attacks. So it's one of the worst case scenarios I always worried about as a CISO, because not that it would damage us. I was really most of all about politicians deciding that maybe universities shouldn't be trusted with this large bandwidth, and that just don't ever want the discourse to go there. Anyway.
Any other questions? Okay. Thank you.